Hello friends, today we will discuss the topic that is wet spinning systems. In last lecture, we had discussed about the dry spinning systems which comes under the solution spinning systems, and the next topic that is under the solution spinning systems comes is your wet spinning systems. In both these systems, we need to dissolve the polymer into certain suitable solvent. So here you can see that there are different fibers which can be produced by the wet spinning systems. That could be your viscose, that could be your polyacrylonitrile. So for that we need to require certain solvent system and coagulant systems. So as we know that the pan, that is polyacrylonitrile, that has been need to be dissolved, or that could be dissolved by means of DMF, that is generally used solvent for the dissolution of your polyacrylonitrile. So for the preparation of your fiber, we need to select the certain suitable solvent, and after that the solution which we found, that we saw solution normally called as the dope solutions, that need to be extruded to the spin rate. But the difference here is that if you see the dry spinning systems, your spin rate system is in the air only. In wet spinning system also same, and in dry spinning system is also same. But in case of wet spinning systems, the basic difference is the spin rate need to be kept into the coagulation bath line. That is, if you see here, initially whatever the dope solution which has been prepared with this solvent system and coagulation systems, then need to filter out, and then it will pass through the certain metering pump, and then if you see here, then we have the filter unit. That filter unit is kept inside this coagulation bath. So during this time, and in this coagulation bath, that chemical which is used, that will ultimately helping you to remove that solvent which has been used for that dissolution of your polymer. So after that, in coagulation bath, the extruded filament will come out, and during that, in this chemical bath, the solidification of your filament has been taken place along with removal of your solvent by means of this non-solvent and systems or chemical means, and then it to be taken out. So that filament which is coming out of this spin rate and that has been taken out, then need to be passed through certain different other zones that we'll discuss in the next slide. So here you can see this, the same filament that need to be passed through the chemical means, and it has been removed by means of this chemical means, and then finally winding onto your bobbin taken place. Here we can say the generalized process line of polymer, and that polymer need to be dissolved means of this solvent, and that solvent, after all this, the solution need to be processed through the filter unit, and then need to be passed through the pump through the metering pump, and then we have kept this spin rate into the coagulation bath. If you see the in dry spinning system and wet spinning system, this spin rate is in the air only, and here the spin rate has been kept inside the coagulation bath or that chemical bath, by which whatever the solvent which has been used for dissolution of polymer, that has been removed by means of chemically, and after that the filament taken to for the washing, and then need to do to the drying of your filament for taking the orientation in your polymeric chains. Then drawing chambers, same. Then we need to apply the spin finish, that could be the antisthetic, cohesionous properties and lubrication properties. Then we have the dryer, and finally winding of your filament has been taken place in the wet spinning system. Next we will see how these are the components which has been there. Initially, that polymer and solvent are mixed into the reaction vessel having the stirring device, and the solution mixture, this called as the dope solution, that we already discussed, that is a dope solution formation or dope formation is there, and within this vessel it has been degassed to remove the any untraced monomers or air. The next is your filter, which receives this degas solutions and removes any left out physical impurities and it further homogenizes. And next part is your pumping metering pump. So metering pump, as we already said, that it is ultimately transferring your polymeric fluid that solutions under high pressure to the spin rate. And spin rate here, whatever the required, that is generally made up, it is very thin and made up of certain malleable materials and which could have 200 to 600 holes of diameter of in the range of 0.05 to 0.25 centimeter. Then the filament from the spin rate are coagulated in the coagulation bath, which is must be followed by a series of baths to increase the precipitation concentration. So the coagulation bath is the measure part here where the all this solvent which has been used that has been removed. After that we have thus winding assembly. So after coagulation the fiber has to be washed to remove any residual solvent which has been left out and need to be dried, and finally we need to whatever the spin finish or finish we need to apply, and then drying of that filament has been taken place, and finally winding of your tow has been taken place. So next we see what are the basic advantages and disadvantages of wet spinning systems. Basically, if you see, recall that in dry spinning system is basically the disadvantage is that it cannot be used for your staple fiber. It is basically used for your fine linear fiber. So if you see here, wet spinning system is basically suitable for your staple fiber. And this both the organic and inorganic solvent can be used. Here the low temperature is required. If you see the dry spinning systems, we require the high temperature, or you can say the hot air we are supplying. Here the high productions can be possible due to the continuous spinning. Then we have the softener process. Then we have the investment cost is very low in case of wet spinning systems. The disadvantage of this system is it is very the spinning speed. In terms of the spinning speed, it is very slow. Next is the washing and bleaching of the fiber are needed, and third is your toxicity. Due to this, certain solvents and the chemical we need to use. Next, we will discuss about the three spinning systems we have seen, that is well spinning system, dry spinning system, and wet spinning system. What is the in terms of different features? Like if you say about the investment cost, the melt spinning system is very low and followed by wet spinning system and dry spinning system. The dry spinning taking the high investment costs because we need to supply the hot air. All these components are very need to be taken care. So the investment cost in case of dry spinning is very high. The next component is the toxicity or hazardous. As we know that the hazardous is the dry spinning systems, or toxic is more because there is a risk of explosion in case of dry spinning systems. Or similar, there could be toxicity more where because we are using these certain solvent, non-solvent systems and the chemicals we are using. And while in case of melt spinning, we doesn't require any chemical and other things, and any solvent we are not using. So in terms of hazardous, the melt spinning system is non-toxic or non-hazardous. Next is the heat of spinning. This means heat of spinning के terms में हम we can see there are melt spinning systems is having the we provide the more heat or more temperature, while the dry spinning system also required more temperature, because in melt spinning system for melting of your polymer chips we need to supply the high amount of heat. In wet spinning system it is much more lower. If you see in terms of the spin rate holes, the spin rate holes, the capacity is more in case of your wet spinning systems, which could be 20,000 to 75,000 spin rate holes can be accommodated into the spin rate plate. And in case of melt spinning, we can go from the 2 to the many thousands, because in melt spinning system we can produce the monofilament or multifilament also. And if you see here, In terms of the spinning speed is more in case of mesh spinning systems and dry spinning systems, which could be in the range of 25,000 to 2500 to 3000 feet per minute in both the cases, while very low spinning speed in terms of wet spinning systems, which is in the 150 to 300 feet per minute. So till that we have discussed about all the spinning systems, what are the different components, how the spinning has been taken place, what are the different fibers which can be produced by mesh spinning systems, where mesh spinning systems required the polymer should not undergoes the thermal degradation. That could be your polyester, that could be nylon, that could be your polypropylene, polyethylene. While in case of dry spinning systems, the whatever the polymer we are using, that whatever the solvent we are using, that need to be evaporated by means of hot air. In wet spinning systems, that spin rate had need to be kept into the coagulation bath, and the solvent has been removed by means of chemical means. So I hope you understand all the basic concept related to the melt spinning system, dry spinning system, and wet spinning system, particularly in this video. So stay tuned. Thank you so much for kind attention.